Welcome back to Andersen Acres. We're here with Gemini today because we are going to talk about yet another rabbit gene. We are going to talk about the fifth gene that we usually list, and that is the E gene, the extension gene. Now, the extension gene impacts how the base color moves around the hair shaft. So she is not extension, she's non-extension. So she doesn't have any extension in her. The reason she's here today is she can throw an extension. So she is big E, little e. And I'll explain what that little e means in a minute. But she can throw that little e. And actually so can Capricorn. But we did Capricorn last time. So today we're doing Gemini. And I will show you pictures to demonstrate what the rabbits that display the extension genes look like. But basically, the extension gene controls how the base color moves around the hair shaft. So her base color is black. If she was displaying an extension gene, this black would kind of move around that hair shaft. Okay? It extends the color and basically just pushes it around. So let's talk about how that happens. There are 4 genes that make up the extension series. So the first one is the most dominant. Sort of. It's the steel gene represented by ES. ES is steel. Steel is the black basically moves down the hair shaft and sits at the tip. Or the brown, if you're talking about a brown rabbit, it moves to the end. So that's where you get the black ticking at the very end. This is not a gootee. A gootee is when you have 3 to 5 bands of color on that single hair shaft. This is literally the base color, the black or the brown, moving to the tip. So only the tip of those hairs have that color, and all of the hairs have that. So a steel rabbit is ticked with just that black. Okay, that's the first one. It is the most dominant, but it doesn't always show up, so it's an incomplete dominant. Usually it reigns supreme over all of the other genes, but every once in a while, the second gene, the non-extension gene, can kind of take its place. So the second gene is just a straight E, large E, big E, okay, the big guy. This is actually non-extension. This is one of the genes that is named for its more recessive traits, not its dominant, because the dominant trait does tend to be non-extension. Gemini is a non-extension, okay? She does not display any extension at all. There is no movement of the color along the hair shaft. Each hair shaft that is black stays black. Okay, it's black the entire way. So when I brush her fur up, you're not seeing any other colors. You're just seeing the black. Yeah, you're a good girl. I know. Oh, I love you. Anyway, now I have rabbit fur on my face. Excellent. But the full extension, she is non-extension. So then we move into more fuller examples of extension. The one that people seem to like the most is the third gene in that series. It's the EH gene, little e, so it's recessive to the other 2, but it is slightly more dominant than the 4th gene. And the EH gene is the Harlequin or the mosaic. This one basically moves the color around on the rabbit. Okay, so if she was Harlequin, if you look at the pictures on the screen, that's a Harlequin. If she was a Harlequin, then she would have patches of probably the tan color that she has and the black. They might be in stripes. They might be in almost a patchwork. There is no controlling the pattern. So breeders have been trying to breed for the specific pattern for years. As far as we can tell, the pattern of a Harlequin is randomized, but it is controlled by that specific gene. So she is not a Harlequin, obviously. But if you combine the Harlequin with a gene from the C series, you can end up with a magpie. Magpies are, remember, C series removes the yellow? So magpies, you just remove all the yellow and suddenly your Harlequin is just black and white and he's a magpie. And they're adorable. If you have them, that's absolutely adorable. So genes from the C series can impact genes from the E series, and you can end up with some really interesting looking rabbits. Okay, you can start to remove that yellow and can get some really neat patterns, really neat colors. And it's one of my favorites, even though I hate the C series. I love the way the C series and the E series can work together to get you some really interesting colored rabbits. So genes from the C series are the reason we have magpies. You need the C series and the extension genes together to make a magpie. So then we come to the least dominant gene, and the gene that she can throw. Okay, that little e, the baby e, or the baby bunny. You're a baby. She's not a baby. She's my oldest lop, but I love her. She's still a baby. But that little e is the least dominant. So if any other genes are present, it does not express. Okay, she carries a big E, non-extension, and a little e. That little e is Tort. Now what the Tort does is you end up with color at the extremities, the ears, the nose, the feet. Okay, you end up with the black, or if it's a blue rabbit, you might end up with a blue Tort. But you end up with this black moving along the hair shaft and hiding on the really short hairs. So if you look, the hairs on the ears, the nose, and the feet are the shortest. Okay, those are the shortest hairs on your rabbit. So when you extend that black color, you don't really see it on most of the Tort with that final E series, the little e. The color kind of moves down the shaft and kind of camps out. And so on longer hairs, it'll just look like you took the black away and you just have that yellow look. But what's actually happening is that black is kind of just camping out near the skin. So when you have the shorter hairs on the ears, the nose, and the feet, what you're seeing is the black or the blue or the chocolate or the lilac, depending on the color of your rabbit. But what you're seeing is that color because it's camping out next to the skin. So that's forcing the black or the dominant color back down into the hairs. So it's not like it's removing. It's just forcing it down into the hairs next to the skin. So you don't see it over most of the body. You only see it on those shorter hairs of the feet, the ears, and the nose. So that's how you get Torts. And yes, I will be introducing a Tort. She did have a baby Tort that I sold earlier in the year. The Tort's name is Charlotte. She was sold to a very lovely woman who absolutely adores little Charlotte. And we are hoping to breed another one similar. I'd rather a black Tort rather than a blue. And I would like to keep it because we do want a Tort in the group. I just wasn't sure about keeping Charlotte herself because she was a blue Tort instead of a black. Anyway, those are the 4 genes of the E series, the extension series. So remember that extension just controls the way that hair moves along the hair shaft. It can force it up like the steel. It can force it down like the Tort, or it can force it kind of around the body, and you can end up with a Harlequin, a patchwork. Or like Gemini, you could be non-extension entirely, and then the gene has no effect. But that is about it for here today at Andersen Acres. Next week we will come back and we will talk about the broken gene because I haven't actually talked about that yet. We'll do that next week. We'll see you tomorrow.